Welcome back to this third lecture on the growth of functions. In previous segments, we studied reference functions and then functions obtained by addition of existing functions. In this segment, we're going to study the growth of functions that are obtained by multiplication. Now, even though we have already used this result, let's present it formally as theorem number 2. This theorem states that if a function f1 is bigger of another function g1 of n, and a function f2 is bigger of a function g2 of n, then the product f1 times f2 of n as a function is upper bounded by the function obtained by multiplying the two upper bounds for f1 and f2, namely g1 and g2. Now let's test our understanding of this theorem by answering a few true-false questions. The first one asks whether the function n to the power 3/2 is bigger of n log n. In other words, is this function upper bounded by this one? Or does this function grow faster or no slower than this one? But to answer this question, we're going to rewrite this function as the product of n and n power 1/2, or square root of n. Now, clearly, this part of the function is identical to this part of the upper bound. So all we have to do is to compare the log n function with the square root function. And you should remember, and again, this is the last time I'm going to include this table here, that the square root function grows faster than the log n function. So in other words, the product of n with the square root of n grows faster than the product of n with the function log n. And as a result, it is not the case that this function is upper bounded by n log n. So the answer is false. So the key point I want to remind you of here is that any function that's defined as n to the power of k, where k is a real number between 0 and 1, not included, any such function grows faster than the logarithmic function. Now our second true-false question is the following. Is the function n log n bigger of n to the power 3/2? Notice in this case the role of the function and of the upper bound is reversed compared to the previous problem. So therefore we can use the same reasoning and decompose the upper bound as the product of n times square root of n. Since n is identical to n and log n grows no faster than the square root of n, the product of n and log n is indeed upper bounded by the product of n times square root of n, in other words, this function. Therefore, the answer to this problem is true. Now let's turn our attention to our last true-false question. Is the function log n to the power 3 bigger of n? Again, we're going to use the fact that the function log n is bigger of n to some power k, where k is any real number strictly larger than 0 and strictly smaller than 1. So which power of n should we choose in order to answer this question? Well, since we're going to utilize the result in theorem 2, we know we're going to want to multiply functions together. In particular, the log n function is going to be multiplied with itself 3 times, And so what we want here is the function, a power of n, such that when you multiply it with itself 3 times, you end up with the identity function n. Well, that power clearly is 1/3, since n to the power 1/3 multiplied with itself 3 times is equal to n to the power 1/3 to the power 3, in other words, n to the power 1, or n. So let's pick this big O relationship as a direct consequence of this table as our starting point. Let's rewrite it here, and now let's use theorem 2, where f1 is this function, g1 is this function, and then f2 is this function again, and g2 is again this function. So log n times log n is log n squared. This function times itself is n to the power 1/3 squared. Now this big O relationship is a direct application of theorem 2. Now the function we're interested in, this one, is just the product of this function and that function. So we can use theorem 2 to infer the big O upper bound of this function simply by multiplying this function by that one. So again, the direct application of theorem 2 here uses this function as f1, that function as f2, this function as g1, and that function as g2. So when you multiply f1 and f2, you get this function, and when we multiply g1 by g2, we get that function. Of course, that function is nothing but n to the power 1, which is equal to the upper bound we're interested in here, and therefore the answer to this true-false question is clearly true.